In this video, we'll look at validating and interpreting clusters. If, for example, we have used several K, how do we decide which clustering results to go for? Also, if we have the clustering results visualized, for example, how can we interpret it and profile it so that we are able to characterize these clusters? So if we look at what we have right here as the output from our rapid miner, to get to this point, all you have to do is, that's on this cluster model, you can click this place for the description, you can click this place to know, the folders, the items in all these different folders. And that's why we said we needed to put your ID there so that you're able to know which one of those particular transactions fall within which particular cluster. And then, we looked at the graph the other time. Then the Centroid table, we'll look at that in the next, 1 or 2 slides. And then this is where we have actually clicked. That's this plot. So given the fact that we picked 5 clusters, that's K is equals to 5, giving us 1, 2, 3, 4, 5. If we click on this plot, we're able to see this particular output. Now, these are the attributes that we used. Like we were saying in the previous video that the results didn't give us well-separated clusters, but we'll still try to make some meaning out of it. So to characterize the resulting clusters, we examine the cluster centroids. That's using this line charts that it has given us. So also known as the profile plot. So we can see from here that the cluster results, that's for 5 clusters, the result that it has given us, that there's not much separation in the data, okay? But nevertheless, you can still pick out some distinct attributes. And to do that, this is the section that has this the most distinct attributes, sorry. So, for example, we see that the main distinguishing attributes for cluster labeled 2, that's cluster 2, this particular one. So let's look for the color right here. So this is it. Is the age. Is the age that is the most distinguishing attribute for that particular cluster. And we're using this particular profile also. We can also be able to see attributes that do the best job of separating the cluster, and that is between tenure, age, list price, and purchased past 3 years. And if you look at it, if you look at the data that we have, you see that they are numeric attributes. So these categorical attributes, they're not really doing much job of separation as it were. So that's one thing that can inform if like we said, it's an experiment, you go back and then you look at your variable inputs again. So that's one thing that can inform the variables that you might want to remove because they're not really contributing to the separation, and try to run the clustering experiment again. So this output was gotten by clicking on the performance vector, and then you have all these 3 options. So if you click on this particular option, it gives a better breakdown. So looking at this now, this has given us the performance of the clusters, that's the 5 clusters, using the average within centroid distance and also David Baldwin results. So looking at the performance results, we have the David Baldwin, which is actually minus 2.341. To make the best decision, we take the absolute value. That's if we have several K. For example, this is another K. So if we look at the Baldwin for this now, that's minus 3.0. So if we take the absolute value of the 2 of them, we'll see that this one is lower than this one. So we usually, the best clustered results usually has low David Baldwin results. So that gives us the idea that this is the best option if we are picking out of K is equals to 5 and K is equals to 2. But we are supposed to even try several Ks. Maybe K is equals to 4, 7, 8, and so on and so forth. So, and then look for which one is the best David Bolden result, so the lowest one. Actually, this David Bolden result probably won't have even been minus if, for example, when we're setting our parameters for the performance, that's at this section, we clicked this. So if we click this, it will give us positive values, for the David Bolden results. And the reason for that is that it's just the minus just helps us to maximize the result. And then, but what we are just saying is that to conclude on the David Bolden, even if you didn't click this place, and you have your results in negative, you take the absolute value. But if you click this place, you have it as positive. So you go for the cluster results that has the lowest David Bolden value. So now for the average, within centroid distance, we also want to look at the one that has the lowest average within centroid distance. So if you look at this now, we see that this, if you find the average, if you look at them, you see that this within centroid distance, that's the absolute value, is still low compared to this one. So that means that this is the best choice, out of these two. But if you try several ones, you are able to pick which one actually is better. So moving on to the centroid table. So the centroid table, back to our cluster model, tab. If we click on it, the centroid table is right here. So we'll click on the centroid table. So this is about 5 clusters, 1, 2, 3, 4, 5. So the centroid table helps us to characterize the resulting clusters. So we examine the cluster centroid. So if we had a very good separation, for example, out of this centroid for cluster 0, if for example we had, this is looking like the highest, so we need to scroll it down and see the remaining. So if this is the highest, this is looking like the highest, but if we have the highest, so maybe 12 points, and all other values are like this, we will see that for that particular attribute that has this centroid, value for this cluster, it's kind of defining that particular cluster. So we can say, okay, that product class minimum is high. So that's how we can describe this cluster. So this is a cluster of customers that their product class, when it's minimum, that is very high. Or maybe if this was the value that has a minus, centroid, that's tenure, has a high minus value, then we can say that the tenure is high on the negative aspect. So that is how we can actually describe these particular clusters. So if we are looking for a cluster, if we have been able to describe a cluster, that has high income, for example, that means that for all those people that are in that cluster, they can be characterized with high income. So whatever you're going to target to them will be towards, maximizing that high income attribute that you have discovered. So that also leads us to giving us a name, an appropriate name for describing that particular cluster. So there are suggested ways that we could have used to improve the result of our clustering. So when you're trying it, so that's an exercise for you to try, and then try to remove some of those attributes and see whether you can get better separation when you visualize it using the profile plots, that's that line plot. So try using only numeric attributes, for example, because we have seen that they are the ones that does the job for the most, that helps us to separate the variables better, or separate the data, better. Then try removing all correlated attributes greater than 0.2 and less than minus 0.2, and then just see what happens. And then remember that the whole idea is to get distinct clusters as homogeneous as possible. So this is an example of another plot. This is not for our Noodles retail practical problem, but I just wanted us to see, for example, if we used another data or we used another variables, the variables in a different way, how the clusters would have looked like very separated. So we can see that, for example, this variable quantity ordered does a very good job at separating the data into different clusters. So we are looking at this, you can see that this is very separated. They are not even close to each other. 1, 2, 3 clusters. They have different you know, characteristics when it comes to quantity ordered. So this is the kind of separation that you are driving at when you are trying to recombine your attributes or your K for better clustering results. In the next video, we will try to introduce the real business problem, which will serve as the default project in week 4.